Welcome to our Data Superhero Lightning Talk session. In this session, we will be talking about 4 different topics. We've got 4 different data superheroes here. We're each going to be covering a different topic. We have 5 minutes per topic, so we're going to be delivering it at lightning speed, so be sure to pay attention. First up is myself. I'm Chris Hasty. I am a data practice lead in EMEA for a global consultancy called Interworks, focusing on BI and data and IT. I'm here today to talk to you about metadata-driven ingestion. We're going to be talking both about inference and automated schema evolution. So let's dive right in. Firstly, we're going to be dealing with a few file formats. There's nothing particularly special when it comes to JSON and Parquet here. One thing I do want to highlight with CSVs, you can see I've got this option on the screen here about parse header equals true. If you're going to be doing any of the schema inference stuff with Snowflake, you need to make sure that parse header is enabled, because that's what tells Snowflake how to understand that CSV should be parsed as a metadata file. JSON, there's nothing special going on here. I've just got an example up. And again, for Parquet, there's nothing special going on. I've just introduced 3 file formats, so we have a bit more flavor for the demo. So, inferring schemas, first of all. You can see at the top here, the SQL is exactly the same. It doesn't matter which file format you're using. It's the exact same process. Snowflake have introduced this functionality for inferring a schema, and that will understand the metadata for a file instead of the file itself. For things like Parquet, where the data types are already inside the file, this is great. Snowflake can understand it directly. And you can see at the table in the bottom here, the output, we have things like the column name, the type, the order, etc. For things like CSV and JSON, it's just worth keeping in mind Snowflake will do its best bet on what the data type is, but because the file format doesn't contain it, it has to approximate, and you might just have to double check it in some cases for things like the length of strings and that kind of thing. So how can we use this? Firstly, we can wrap this into a list of objects, and in this list of objects, what we can do is it's the exact same thing. It's still the column name, it's still the order, it's still the data type, but we can put this as a subquery inside another statement. And that statement is this create table using template. And when we use this, what table creation does is instead of us providing the column names, the data types, the order, etc., this will automatically read the information that we've given it based on this inferring schema, and it will create the table to match. When we then go ahead and do this copy into, we have a match by column name option. And this is just what tells Snowflake that, yeah, pay attention to the fields, to the metadata of the file, and ingest it appropriately. That way, if you have something like a CSV where your fields are in a different order, it doesn't matter, and Snowflake can identify it by field name and ingest it in. And this is exactly the same, just to reiterate, whether you're doing it for CSV, JSON, Parquet, Avro, Awk, like they all have the exact same structure. So we're going to make it a bit more interesting. We're going to look at automated schema evolution. And for this example, we're going to load data from 3 different sources into one table. And these files all have a slight difference to them. They've got some fields in common, but they also have a few differences. A couple of fields that only are in the CSV, a field that's only in the Parquet, just to make it a bit different. To load all of these into the same table, we're first going to create that table. And I've just created a basic table. None of the fields from our files are in this table yet. We just have some metadata. I love metadata. I put it into everything I do. So we have the file path, row number, ingestion timestamp. The important thing to note here, you can see underneath those, the enable schema evolution equals true. And what this particular option does is this is what tells Snowflake to enable the automated schema evolution, where new fields will be added automatically to the table. If we skip ahead and start ingesting our CSV file, we use a standard copy into statement, and we again use this match by column name. And the match by column name, as I mentioned before, is what tells Snowflake to understand that metadata and ingest it. I've also got include metadata just because I love that functionality. It's relatively new in Snowflake and it's really useful. You can see at the screenshot on the bottom here that that's automatically added that event ID, group, date, etc. Those fields have been added to our table without us needing to do it ourselves. And the ingestion goes through nice and smoothly. There's nothing particularly interesting right now, just data that's landed in the table, but we know it's all happened without us having to define anything manually. Skipping forward slightly, going a bit more interesting and looking at the JSON, Here we have the exact same functionality before, the exact same statement, just pointing at a JSON file. And those two new fields are automatically added to the table. When the ingestion takes place, anything that is present is ingested. Anything that wasn't present is a null, which I think makes sense. And for completeness, we'll wrap it off and just import our Parquet file as well. An exact same process, exact same structure of the query. New field gets added. And then as you can see, the new field populated where available, and everything else is null. And that's it. That was our lightning introduction to automated schema inference and evolution. Thank you very much for listening. Over to Dendu.
Thanks, Chris.
All right. All right.
Work.
Thanks, Chris. Hey, everyone. My name is Sudendo. Work at Kippy, of course, a data superhero, 2 years down the road. Traveled all the way from Dubai, so it's a long flight. And as you can see, I lost my voice on the very first day. So I'm glad the session is on the third day. So I'm going to talk about something I've been working on with my team. This is on energy and utilities section. So, the use case revolves around the solutions that we have built around smart meter data. So you would imagine, big utilities companies around would have a lot of data coming from meters, from logs. The idea would be to, leverage Snowflake. In most places, it's already been there as a central data cloud, where you move in not only your meter data, but also get in your CRM data, your sales data, your weather data, all other third-party, second-party data into one place. A solution like this unlocks a lot, and specifically, within the last couple of months with the new announcement around AI/ML Cortex, there's a lot of plug-and-play thing you can do right away. So it could be demand forecasting, it could be anomaly detection, it could be theft detection, it could be giving out notification, giving out warning, right, just to your end customers. So a very good example I've seen where it works is if I leave my tap open and leave for office, I get a call within 1 hour from the water department that something is wrong, your usage is not in your normal distribution, can you go back and check? So this is a solution that we built. It's all within Snowflake, of course supported by AWS's features, and I'm going to go a little bit into the architecture. So this is how it looks. You go left to right, of course. So the source system could be your metadata to start with. So this could be all your metadata in one place. Coupled with it, you can bring your logs data, your metric data. What we have done in this solution, as you can see over here, is we have taken marketplace data. So we have taken weather data from the marketplace, but we have also taken a bunch of data in various formats, both streaming and batch. Using Amazon Kinesis host, we plug that data in using Snowpipe streaming. So you'll hear a lot of Snowflake features that are being used over here. So we start with Snowpipe streaming. We get the streaming data in. We get the batch data in using Snowpipe, the usual Snowpipe. Once we have it, we move it to multiple layer, as you can see. And we use dynamic table for flattening and data modeling on the fly as we are doing it. Once it is at the end, this is where we do two kind of analysis. We do normal data analytics, and then we go with the AI and ML modeling. So we use a lot of Cortex feature. You'll see some of those down there, but we have used most of the Cortex features, and if not available, we have brought in from the outside using Snowpark, and we have tried Snowpark Container Services as well. It's a brand new solution, but we are evolving on that. Everything is then packaged around a Streamlit native app. So you have everything right within Snowflake. So you get, your users, your managers, your board would usually go plug it in, get into it, and you can see so I put some graphs down there, but there are many out there. But the idea is the possibilities endless with use cases like this. It's a 5-minute talk. I'm not sure if I'm on time. Maybe I'm a little early, but if you wanna talk more, that's my LinkedIn down there. But I'll let Fabian take it over now.
Thank you, Sundandu.
Yeah.
Should be this. Hello, everyone. My name is Fabian Hernandez. I work as a senior data architect and infrastructure solutions. My background is computer science, but I also hold a master's degree in statistics and another master's degree in machine learning. So for today, I want to talk on how to do advanced LLM operations using the latest Snowflake model registry library. I want to talk about that in the context of a project that we delivered for a customer back on December last year. So this customer wanted to build a customer classification system to understand their customer reviews better, right? So this is the architecture that will be for the client. But more than a POC, we wanted to build a production-ready system that could help the company to accomplish three things. First, we want to be sure that different model versions and feature versions could be managed by the system. Second, we want to be sure that a proper CI/CD process for deploying new models was in place. And third, we wanted to democratize the access of the solution for non-technical users, right? So we ended implemented all of this architecture using all of these technologies. We will require a longer session to talk about all the components. So for today, I decided to talk, to continue the presentation talking about how we solve for model versioning and usability. I cannot talk about that before mentioning what is the model registry library a little bit. If you have been working on machine learning for a while, you will eventually arrive to the same two conclusions. First, there is no such thing as the best machine learning solution, machine learning model, machine learning library. Sometimes a linear regression can do the work just fine. It will depend on the problem that you want to solve and the data you have in hand. Second, you want to keep your development iteration cycles short. You want to do the first version and iterate over that, but by putting that in front of a client and hopefully receiving feedback. The Snowflake team behind the development of the model registry library understood that too well. And they built the library in a way that regardless of the underlying technology that you are using, you can still continue creating new versions using the same approach. Meaning that effectively you can start with one sklearn model, and if you need to move to TensorFlow, you can do it without changing the underlying technology. So how that will look in practice? For our customer, we use the model registry library to pack an LLM for zero-shot classification of customer reviews. Using the model registry library is quite simple. The first thing that you need to do is to implement the custom model class and override the prediction function there. On the prediction function is where you will call your model and your tokenizer. In our case, we use Diverta B3 small. So on that prediction function is where you will put together all the transformer libraries to make the classification. After that, you just need to instantiate the class, providing the artifacts that the model will require. And that's it. With those simple steps, you will be able to get a model that captures and encapsulates all the complexity of interacting with that transformer library. After that, to log the model and to do the deployment, logging the model is also quite simple. You just need to use the log model function, define a name for your problem, define a version, and provide the object that you created in the last step and the library dependency for that model. And that's it. Just by doing that, you will be logging your first model version, and Snowflake will take care of all the dependencies and artifacts within that. To deploy the model, we implement a sort procedure that deploys the model as an UDF. We integrate this with GitHub Actions. So why integrating this with an UDF is a great approach? Well, because if you implement this as an UDF, effectively you can provide access to the model just by interacting with the SQL code. So now, instead of having a necessity of calling Python to do your to get the values from your model, you can just call the UDF and it will get you the same results. That's it. With these simple steps, we managed to implement an automated solution for them, and we effectively lowered the entry point for accessing the model because now the model was accessible through a UDF and pure SQL. That's it. Thank you so much, guys.
How's it going, everyone? Okay, great. So my name is Divyansh Saini. I'm one of the co-founders and the CEO at this company called Houseware. We won the Snowflake Startup Challenge in 2022, and here as a data superhero, talking a little bit about agents. What this is going to be is a very high-level overview of what agents are, and why we think that that's going to be the next level of evolution for enterprise software. So agents are the new software. Now, Andreessen Horowitz is a very famous Valley-based VC firm that talked about software is eating the world. This was probably more than a decade ago. Now we think that agents are going to be eating software. And if you think about agents at a very high level, these are essentially mimicking human behavior as a knowledge worker, someone like yourself and myself. The kind of things that we do on a daily basis is happening in the scene, behind the scenes. Think of it as an LLM on a for loop, always running for you. So the 4 critical aspects of an agent that typically are talked about are memory. What can you remember as a person who is a knowledge worker? So when you start your day, you already know what your organization is up to because you have that memory in you. The tools that you have access to. Now, a lot of us use Microsoft Teams, Slack, email, Zoom to interact with our coworkers. An agent also has similar tools like calendar, calculator that it has access to and can call on demand. The actions that we take on these tools, and finally, the planning that we do. So when you get your morning coffee, you're figuring out how your day or your week's gonna look like. The agent is able to do that. It's able to reflect. It's able to figure out how it can critique itself and the steps that it's taking for you, and then reinvent that on, again, a for loop for you. Now, we obviously heard about Cortex AI, which is obviously a new service that Snowflake has been tinkering around with for the last year or so. At Houseware, our team started to work with Snowflake Cortex AI very early on. And fundamentally, the 2 challenges that we face as an engineering team to build agents is what we have tried to solve for developers en masse so that people do not have to face the same challenges again. And those 2 challenges are, one is very behavioral in nature, because if you think about it, we always think about data engineers, front-end engineers, back-end engineers. Now, every engineer has to reinvent themselves as an AI engineer and think about what does an agent do and how do you really reinvent the front-end interface, for example, for an agentic behavior. The second challenge is building these agents, deploying them, monetizing them for the right kind of usage. And that's where things get tricky, because you're dealing with not just a prompt and a model, just like in ChatGPT, which is a very primitive kind of an agent, but you're also trying to tell the agent to think in a certain way, in certain steps, and then reflect on it, human input coming in, and a lot of other things happening, right? So that's where things get tricky, because you're combining unstructured, structured data with a model that you're fine-tuned or you're using off the shelf. So we built this end-to-end developer toolkit for ourselves natively on Snowflake. This is going to be released very soon for everyone to be utilizing. And what I'm going to do is, I'm not going to talk about each of these things. What I'm going to do is do a very quick blazing demo, because this is a lightning talk. So you're going to have to keep up with me on this one. And let's see if we can get this running. All right. So what you're seeing right now on the screen is all the agents that are available in the Houseware user interface. So you see that there's sales agent, so I'm going to click on that. The sales agent essentially is an agent which fetches information from your sales data and pushes it on a real-time basis whenever the new information surfaces onto your Slack. So let's see how we can build this agent. The first interface that you see here is to give some base instructions. So just like, when we are getting a new task or a new project, someone in our team is probably going to brief us about what this project is going to look like. Similarly, we fine-tune this agent to be knowing and thinking about certain kind of tasks and instructions that we want to be giving it. The next step is the tools that it has access to. So Houseware has pre-built some of these tools so that developers don't really have to do this all over again. And some of these tools are fairly basic that come into every action that an agent is going to be doing. Something as simple as browsing a web interface, accessing a table on Snowflake, sending a Slack message. So I'm going to select some of these tools that are available. I just selected query table, and I can see this sales data, which is available on Snowflake for me. So you see it says product ID, product names, which seems like these are iPhones, which region was it sold in, what's the sales amount, and things like those. I'm going to click next and also select the tool, which is send Slack message. That's what we intend to do here. What we can do next is we can also figure out the plan for this agent, how this agent should be thinking. I'm going to skip this in the interest of time, but you can basically define what should be the parameters in which agent should be thinking, and add the vector files or the embeddings that you have access to as well. Finally, I'm going to go to the playground, and this is an interface I think that almost everyone is familiar with, even my grandfather. So what we can do is we can essentially type in a prompt, which is give me an overview of the sales data and send it to Slack. So we're going to run it. And as I said in the very beginning, an agent is basically an LLM on a for loop. It has started to think about the process that we are looking to invoke, which is essentially querying the run tool, querying the table that we selected on Snowflake, run the Slack message tool, And then finally, what you see in the end is a Slack message popping up into my Slack interface. And I can see all the data about iPhone sales, which are summarized in a certain way that I wanted it to do as per the base instructions. So that's all from me today. And I hope this gave you a very high-level overview about what agents can do. Thank you so much.
Cool.